Okay, so page 5 in your packet. Couple things real quick that you should know already, but I just want to refresh. So who can tell me what the duet rule is? And which elements that the duet rule applies to? Lissa? That's right. So hydrogen and helium want 2 valence electrons. That's probably about as short as I can make that definition.
I think you can do it.
All right. So when it says atom, really it's talking about hydrogen here because helium already has achieved the duet rule. Hydrogen is the one that wants it. And then the octet rule, you can probably figure, is all other elements want 8 valence electrons. Okay? Everything else wants 8. All right.
I can't reach from that far.
Jimmy, that is the exact perfect, but I think you should see.
No, man.
Now, you guys remember last week when I gave you the term Mr. Brinkelhoff?
I don't remember you mentioning
I do, I remember.
These are all of your diatomic elements.
it. Oh, yeah, you did say that.
Okay, Mr. Brinkelhoff. Now, if you don't have a periodic table, if you do have a periodic table, you can remember it another way. You can remember it by remembering H7. So hydrogen's in here, hydrogen's right here, that's your H, and then it forms a 7. Nitrogen, oxygen, fluorine, chlorine, bromine, iodine. So those elements right there, they are all diatomic.
Wait,
So if you find them by themselves, they'll actually be paired up with another atom of that element.
Wait, so 7, 8, 9, 17, 35, 53?
Yes. All right. Now, let's draw a few electron dot structures for these covalent compounds. Okay, first off, how many valence electrons does fluorine have? All right.
I forget how you know that.
7. It's in group 7, so it has 7. That should be like automatic at this point. Okay? And then draw your Lewis dot structure to a place where the 2 fluorine atoms will have the lone electrons facing each other.
So in the Lewis dot structure, you only have the outer shell. That's
Yeah. Only concerned about the valence in the Lewis dot
it.
structure.
Doesn't matter where you put the dots.
It doesn't. No, but there are smart ways to write them and then not so smart ways to write them. So when you're doing these Lewis dot structures for covalent compounds, you'll want to write them in a way where the lone electrons will be facing each other. Because if not, you're going to have to erase them and then move them to the other side.
Can you remind me of what a valence electron is?
Valence electron is an electron in the outermost energy level.
All right.
So you bring in the other fluorine atom because it is F2, and you have 1, 2, 3. The fourth one will go ahead and pair up right there. 5, 6, 7.
Hold up. What the heck?
Okay? So look, remember last week, there is a sharing of electrons that occurs right here. So in ionic, they give and take. But in covalent, they actually share electrons. So again, you don't have to draw these circles, but if it helps you, you can. These show the ones that are shared and then the ones that aren't shared. So the ones that are overlapped right here, those are the ones that are shared. All the other ones are the ones that are not shared.
Okay, so I get what we're doing, but I don't
because you're really showing how many bonds that each element
So
has.
this one has 2.
This one has 1. It's a single bond between 2 electrons means 1 bond. Or 1 bond means 2
If
electrons.
it's 4 electrons, does it mean
2 bonds.
and then 8 means
Well, you wouldn't have any more than 3.
3?
You could have a triple bond, but you couldn't have a quadruple bond.
Is 8 a triple bond?
6.
So it's just whatever it is times 6.
Yeah. Okay. All right. Now, let's take a look at oxygen. I'm actually gonna put this one in pencil because I'm gonna have to erase on this one.
It'll be the 2 O's next to each other.
Well, that's all that there is to bond, so yeah.
Valence electrons.
All right.
No, there's 6.
So
There's right. Isn't there only 6
There's
valence?
6.
There's 6 valence electrons
Why do you tell me?
in oxygen.
And that's
Okay.
the-
It's okay.
So-
It's okay.
1, 2, 3, 4, 5, 6. And again, it really doesn't matter where you put the dots as long as you have 2 that are by themselves and then 4 of them that are paired up. Like here's 2 that are paired, here's 2 that are paired. So that's 4 that are paired, 2 that are by themselves. Okay? You bring in the other oxygen. And you got 1, 2, 3. The 4th one I'll go ahead and pair up like that. 5, 6. So what that leaves me with is 2 lone electrons that are not part of a bond. They all want to be part of a bond, okay? They want to be paired up. So here you have these 2 electrons. Go ahead and take those.
Oh, I did not know that.
And pair those up in the middle. Okay? And it'll look like that.
Oh, now I
So you're just trying to get them to the middle?
Well, you need as many in the middle as you need to be able to have 8 valence electrons.
It's
So
since they can't be alone.
basically, yeah. Okay, so if I color over that in pen so that you can see a little better, this will look like this. So what this means is that oxygen has a double bond. Okay? And there's your circle if you want to draw that. And the electrons that are part of the bond, and then these are all the electrons that are not part of the bond.
So why can't you put them in?
Well, they're already paired up. They're already paired up on the atom.
Okay.
So they don't need to be paired. I mean, remember, every element wants 8 valence electrons. So it's going to do what it can to be able to get 8. Well, this allows both these atoms to be able to get 8 by sharing 2 electrons.
Oh, well,
2
this
pairs of
next
electrons.
one is gonna be interesting.
Okay? All right. Everybody with me so far? Haven't lost anybody?
I'm right here, Mr. Harrington.
Okay, that's good, Jeremy. All right, next one. You have hydrogen sulfide. Which technically this is a covalent compound, so you would name it dihydrogen sulfide.
So there's 2 H's.
You have 2 hydrogens. Now, first thing you have to decide is which element's going to go in the middle. Anybody remember what I said about that when you have hydrogen?
Put the hydrogen in the middle.
No.
No, put the hydrogens on the outside.
You never put hydrogen in the middle. Hydrogen cannot go in the middle because hydrogen can only make 1 bond because it only wants 1 electron. Therefore, you can't make 2 bonds if you're in the middle. Okay? All right. So that means the sulfur is going on the outside. And sulfur has how many valence electrons? Anybody? 6.
Oh,
1,
I think I did it.
2, 3, 4, 5, 6. And then your hydrogens, you bring in right here. It has 1 electron. The other hydrogen you bring in, it has 1 electron. And now everybody's happy. Your hydrogen ends up with 2, which is what it wants. Hydrogen ends up with 2, which is what it wants. And the sulfur ends up with 8, which is what it wants. Everybody's happy.
Why does hydrogen want
Remember, hydrogen only has the first energy level, and the first energy level can only hold 2 electrons.
to?
All right, the next one is carbon dioxide. Carbon dioxide is tricky. But I will tell you this, carbon dioxide is one that you will see in the future. Maybe on a test, quiz, something. But you will see this in the future, so you need to know this one. All right, now there was another thing we said about elements going in the middle. Anybody remember what that is?
Not oxygen.
Well, oxygen can go in the middle, but
I put oxygen.
what we said is that the element that is farthest to the left on the periodic table, meaning the one that is more metallic, furthest to the metal side, even though it's not a metal, but technically more metallic than oxygen, that one goes in the middle. So carbon's going to go in the middle, oxygen's going to go on the outside. So carbon goes in the middle. How many valence electrons does carbon have?
4.
It has 4. I'm actually going to write this in pencil because I'm going to have to erase. All right. So 1, 2, 3, 4 valence electrons right there. And oxygen is going to go on the outside. How many valence electrons does oxygen have? What group's it in? Not 8. It's in group 6. 1, 2, 3. The fourth one we'll go ahead and pair up. 5 and 6. Same with the other oxygen on the other side. 1, 2, 3. The fourth one we'll go ahead and pair up. 5 and 6. So this is what you end up with right here.
Wait, did I do this?
Hold on. You can check it in a second. So what's going to happen is this. Carbon has 2 lone electrons that it wants to pair up. Each oxygen has 1. So what this means is that you take that electron from carbon, that electron from oxygen, pair those up to form a double bond. And then you take that electron from carbon and that electron from oxygen, and you pair those up to form a double bond. So what you end up with is 2 double bonds. And it ends up looking like that. Okay? If you want to draw your circles, you can draw your circles. And there you go. Everything gets 8.
We have to do this whole thing.
We will eventually. Probably not today. Am I confused?
It's just part 1 of 6 of the whole. I'm just kidding. I think I kind of get this.
Good.
I still don't know if I
Yeah, Grace.
Because I feel like
I know you got, like, we have the 4 and the 2 oxygen and
Mm-hmm.
carbon. How, like, did you just reuse the same one on the other side? Like,
No, it's 2 separate groups of electrons.
like, how did you get 4 on each side?
Well, you got to make sure that you position them in a way that allows you to do that, because that's why I say you need to be smart with where you put your elements. 'Cause if you know what you're doing, so carbon has 4 valence electrons. Okay, you put 1 on each side, top, bottom, left, right. I would bring you normally want to keep things symmetrical. So there's 3, 4, 5, 6. Bring in the other oxygen. It's got 1, 2, 3, 4, 5, 6. Take that electron and that electron, pair those up. Take this electron and this electron, pair those up.
Did I do it right? Because mine looks different.
I don't know, I can't see
There's
that.
multiple different things. They're going to be in different spots. It's just the same number of dots.
No, you don't have 2 double bonds. So the key here is you have to have 2 double bonds, one on each side. Okay. All right, jump down to where we're at with nitrogen, N2.
I actually thought I did.
Now, look at where nitrogen's at. Nitrogen's in group 5. How many bonds do you think nitrogen wants to make if it is in group 5?
6.
How many electrons does it need?
8.
Tanner's got it. It's 3. Okay? It wants to have 8. It has 5. So that's 3 electrons away. So it's got to bond 3 times. So look, if the only thing that's there to bond is another nitrogen, they have to bond 3 times between the 2 of them. So there's 3, 4. Okay? And then you take these electrons here. Pair those up. Take these electrons here. Pair these up. And now everything is good to go. All right, so you end up with 8 on this nitrogen and 8 on that nitrogen. Now notice, it does not matter that I put these 2 on top, to the right, or on bottom. As long as they are by themselves on that nitrogen, it doesn't really matter which of those 3 spots it's on. What?
You're just going to get
Here, like.
It's a triple bond.
So there's ones in between it even?
Yeah, those are the bonded electrons.
Oh.
So that's a triple bond. There's 1 bond, 2 bonds, 3 bonds.
Yeah, but that means there's only 6 per.
No, there's 8. 2, 4, 6, 8. 2, 4, 6, 8. The ones that are in the middle are shared. Okay?
I didn't get that book.
All right, last one I want to do together
Holy crap.
is the last one on the front. So we have boron trihydride. Now, I will tell you this. Boron has a tendency to form a lot of exceptions to the octet rule. And the reason for that is because boron actually it's actually a metalloid, so it will form a lot of covalent compounds, but it's in group 3. So it would have to actually share like 5 times to be considered stable, and that doesn't happen a lot, but it still forms covalent compounds. So boron has 3 valence electrons. Hydrogen has 1 apiece, and there's 3 hydrogens. Look, there's not even 8 electrons in this entire compound. So boron is an exception to the octet rule. Okay? Hydrogen ends up with 2. This hydrogen ends up with 2. This hydrogen ends up with 2. Boron ends up with 6. So that's an exception.
That's cute.
So this says which molecule above is an exception to the octet rule? It's that.
You just got light series.
That's only 6.
Yep, it is.
Jimmy, come here. condition your hair?
Yeah.
I thought boys weren't supposed to do that.